So, a heat engine. A heat engine is a special type of an engine that converts heat energy into mechanical energy. Today we are here to discuss the mechanism of a heat engine. Now, a heat engine, as we have discussed, it is that which converts heat energy into mechanical energy. Okay, in order for a heat engine to work, a heat engine has a heat source and a heat sink. The function of a heat source is to supply heat to the heat engine, and that of a heat sink is to absorb heat from the heat engine. Now, let the heat engine be working in between this heat source and heat sink, as it actually does. Now, by the supply of this Q1 amount of heat energy, the heat engine actually does work. So, if we supply Q1 to this heat engine and it does work amount W, it gives out heat of amount Q2. So, if you draw the diagram over here, you could see that if you supply Q1 heat, it distributes itself in such a way that Q1 is equal to W plus Q2, and thus following the law of conservation of energy. Okay, so how do we describe this Q1 is equal to W plus Q2? And how do we actually describe the efficiency of a heat engine? Well, we know that the efficiency of any particular system, as denoted by the Greek letter eta, is equal to the work done by a particular system to the energy supplied and its percentage, of course. Now, over here, if you follow this diagram over here, the work done is actually W over here, right? And the amount of heat or energy supplied to the system is actually Q1, right? So if we follow this diagram and put the variables over here, you could say that eta over here is basically W over Q1. Okay, so another thing to keep in mind is that the function of a heat sink is to absorb heat, and thus the heat sink will always be at a temperature that is less than that of a heat source. So if we say that the heat source is at temperature T1, the heat source is at temperature T2, always and always T2 will be less than T1. And that being said, we could also say that Q2 is less than Q1. This is basically because Q is proportional to T. Okay, so moving on, we could say that W over here, according to this equation over here, is basically Q1 minus Q2 over Q1, and the percentage signs should be over here, right? Okay, and if we do some further simplification, we can say that this is basically 1 minus Q2 over Q1's percentage, right? And voila. Now, we know over here that Q, as the heat energy supplied, is directly proportional to the temperature of a system. And so we could say that Q1 is proportional to T1 and Q2 is proportional to T2. So we could say that Q1 is equal to K times T1, and over here Q2 is equal to K times T2. And we could basically say that Q1 over Q2 is basically T1 over T2. And over here, Q2 over Q1 is basically T2 over T1. And if we plug this thing over here, we could say that the efficiency is basically 1 minus T2 over T1. And of course, don't forget to put the percentage sign over here. What does this actually mean? T2 over here is basically what? The temperature of the heat sink, right? T2. And T1 over here is basically the temperature of the heat source, right? T2 is that of the heat sink, and T1 is basically that of the heat source. And here you go. This is the efficiency of a heat engine, and over here discussed is the mechanism of a heat engine. Well, that's all.